In this video, we're going to take a look at how to find the pH of salts. We're going to start off with the pH of salts that we're kind of used to seeing from grade 11. And those salts generally have a pH of 7, and we'll take a look at why that is. You might have learned that when you do an acid-base reaction, you get salt and water. So just a little reminder of what that looks like. Suppose I had some HCl and it was reacting with some NaOH. I'm not going to put states right now, but NaOH, so an acid-base reaction. You get this NaCl plus water. And so here you have an ionic compound that's considered a salt. And then you have your water after. So the salt is essentially your ionic compound that results from your acid-base reaction. So salt is just a general term for an ionic compound. We have acid-base. The acid at a pH of less than 7, the base at a pH of more than 7, and when you got here, you saw that your pH was equal to 7. In reality, we're going to see that not all salts are actually neutral. Not all salts will allow your pH to be 7. They'll be closer to 7 than they were before the reaction happened, but they still won't be exactly on 7. So we're going to take a look at why that actually happens. So the first thing you need to remember is that water is able to autoionize or self-ionize. It does that according to this equation. Some of the water molecules will act as acids and some of the water molecules will act as bases within a sample. And you'll get this equilibrium here. You'll get H3O plus OH minus. So let's remember that because it's going to help us to understand what happens when a salt enters water and how its pH could be 7 or it could be more or less than 7. So we're going to start off with these salts of strong acids and strong bases. What does that mean? Let's take a look at an example here, NaCl. NaCl is a salt. What will the pH value of a 0.10 molar solution of sodium chloride be? And you're usually thinking, well, it's a salt, so it's got to be neutral. Not all the time. In this case, it will be, so we're just going to see why that is. But a salt doesn't always have to be neutral. But let's take a look at why NaCl is neutral. What we do is we're first going to dissociate NaCl. We're going to show what it becomes in solution. It becomes Na plus aqueous plus Cl minus aqueous. And you'll notice that when it dissociates in solution, there's two ions that have formed, the Na plus ion and the Cl minus ion. So that's our first step. We wrote a dissociation equation because we need to acknowledge a salt is made up of two parts, the positive part and the negative part. Our next step is going to be to test each ion out with water to see how it would react with water through what's known as a hydrolysis reaction. So let's start with Na plus. We're going to make Na plus go through a hydrolysis where it reacts with water. Now, because Na plus is positive, if it were to react with water, what we would see is the OH would combine with the Na plus because OH is negative. Remember, water is HOH with the plus being the H and the OH being the negative. So we would see if this actually did happen, NaOH plus what's left over, well, the H plus AQ. So the positive ion would be connected to the OH, and then the H plus would be left alone. Now, we're assuming this reaction happens. But look at this carefully. NaOH is a strong base from your list of bases you had to memorize, or by looking at your table, you see NaOH is not in the weak base list. So what does that mean? It means that Na plus is the salt of a strong base. Remember, a strong base will not want to reform once it's dissociated. The strong base wants to go this way. it dissociates 100%. And it doesn't have an equilibrium where it goes backwards to remake NaOH. So once you have Na plus in solution, it's not going to react with water to make the strong base. A strong base is so strong towards dissociation, it will not reform. So Na plus is not going to react with water to form NaOH. That reaction is not going to happen. You're not going to have Na plus producing these Na plus, these H plus ions over here. That's just not going to happen. So this direction does not happen. Because Na plus is the salt of a strong base, and the reaction will not proceed to make H plus NaOH, the salt of a strong base has no effect on pH. In other words, its pH would be 7. But we're not quite done yet. We tested out the sodium, no effect on pH. We got to test out the chlorine now. So Cl minus AQ, let's make it react with water as if it would, because it might. Now in this situation, if it were to react, since Cl is minus, the H plus will go with the Cl to make HCl, aqueous. And then since we remove the H from water, we have some OH left over. So theoretically, Cl minus could act as a base because it's producing some OH on that side, but let's see if that would actually happen. HCl is a strong acid. HCl does not want to be reformed from Cl minus. HCl will ionize 100%. So this direction that we saw here is not going to happen. It's actually just going to stay this way. Cl will not go and reform HCl in water because HCl ionizes 100%. The equilibrium lies towards ionization. So this Cl minus is the salt of a strong acid. And the salt of a strong acid also has no effect on pH because, again, the acid wants to stay ionized. It's not going to reform Cl minus with water to make the acid again. So when you do these hydrolysis tests with each ion, and you see that they're derived or they're the salts of strong bases and strong acids, then you know they won't have an effect on pH, and overall, the NaCl salt is neutral. So in grade 11, most of your titrations that you did, if not all, were titrations where you ended up with a salt that if you did hydrolysis, you would see they are derived from strong bases and strong acids, and that's why their pH was 7. So NaCl, it doesn't matter what the concentration is here, is a neutral salt. Therefore, the pH is equal to 7. So in a situation like this, where I ask you for the concentration of a salt, you first need to write the dissociation of that salt to see what the ions are. And then you need to test each ion in hydrolysis. If both ions are from strong bases and strong acids, then the ions will not have an effect on pH. The pH will remain at 7, regardless of what this concentration is. However, that doesn't always happen. Sometimes you will have a case where part of a salt does not come from a strong base, does not come from a strong acid. It comes from a weak base or a weak acid, and there our pH will be different, and that will require different steps. So in this video, we saw that if you have salts of strong bases and strong acids, the pH is going to be 7 because hydrolysis will not happen. The water will not be used by the ion to go make the strong base or strong acid, since the strong base and strong acid want to remain dissociated and ionized. And that's just a nice, easy way to show the work. You don't have to do any calculations once you've shown that hydrolysis will not happen for either of the ions. In the next video, we're going to take a look at what happens when you have the salt of a weak base or the salt of a weak acid. So we'll do an example where the salt may not be neutral.